So hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with our lead code question number 40, which says combinational sum part second. So it's a medium level question. So what it says, let's read it down. It says given a collection of candidates and a target number target. Find all unique combinations in candidates where the candidate numbers sum to target. Each number in candidates may only be used once in the combination. So we have to keep this in mind, okay? Note the solution set must not contain duplicate combinations. Okay, so let's take this example. So in this question, it seems like our the question number 39, which we did earlier, combinational sum, which was part first. It's similar kind of, but here we have to keep in mind that there should not be any duplicate combinations, and also the combination should use one's number, any number only one time. But in that question, we can use any number of times. That's the only difference here. So let's see our first question. So here we can see this is our array which contains 10, 1, 2, 7, 6, 1, 5, and the target is 8. So how can we form combination here? So we can form combination by various type, like we can form a combination 1 by 6 and 2, okay, and 1 by like this, and 6, 1, 1 and 6. This can also be a combination, and one combination can also be 1 and 7, and one two more another like this. So how we approach this problem? Okay, first of all we have to keep in mind that we must not repeat any values like this. We can't take 5 and 5 again. Sorry, it can't form even also, but we can't take like this 2. We took 2 2 2 2 4 times, that will also form 8. We can't do this. Okay, so we have to keep this mind that once we have taken one element, we can't take it, so we will start from taking next index. Okay, so let's see how we can approach this problem. So to make this problem easier, first step would be we must sort this array. So after sorting, it will look like this. Why we sort it? We sorted it because when we try to check our elements like this, like first, and we will try to check that if we reduce this with a combination, does it will give us target. So when we reach, for example, here we took this, and after adding this we can see that it is exceeding because it is forming 9 and our target is 8. That means there is no point of taking more greater element, means we don't need to go there again. Okay, so that's why we have already sorted it, so that our this work will be saved and it becomes easy for us. Then what we will do, we will start from here. Okay, then again try to make combination like this. If the combination exists, then okay, otherwise then again it failed. So how we can approach this problem? So it's same with the help of our recursion tree. We have done earlier questions also, so we can do the same like this here only. Okay, so let's take this again. This was our array after sorting, and our target was 8. So at starting, our string was like this, empty. Then our index is pointing to 0. Okay, that's our index. So first of all, what we have done, we took it because we have checked that our target is 0. So we took it and we have subtracted it from our target like this. So our target is now 6. Sorry, 1. That's why our target is our 7. Then again we have called this function again that we will be using. Then it again added one element because it's still greater. After this we have again deducted one like this, and we called again this function. Now our I is here, index, and now it is here. After writing this, we again moved forward and we took this. But after when we took this, we can see that now our value is 9, which is greater than 8. Means our resultant after minusing it have definitely gone to -1 like this. 6, then we minus what? 2, which results in 4. Then we minus 5, which results in -1. That means we can't use this approach. Sorry, this tree. Means we have to exit from here. That's why we returned from here, because there, and then we saw that we can't use other combination. Like if we move forward like 6 7 10, this will again result the same. That's why we return back from here. Then here we have already tried 2. Then what we will try? Another values like 5. After trying 5, we see that it will give us 7. That means that we are not needed that. Then we can again add another value. After adding another value like this, we can see that now it exceeds our limit. That means we want target 0, but it gives us something like -2 or 3. Oh, wait a second. Sorry for that. That's why we can't use this tree also, and we recurse back from here and then here. Then we have tried 5. Then what we can try? We can try 6 also. 1 1 6. After trying 6, we can see that our value is succeeded. That means we have got our first combination, because on adding this and subtracting to our target, it results in 0 like this. That's why we push it to our resultant vector and then return back. Then again try it for another combination like this, 1 1 7. Yes, but this fails. Then it again reverts back, and we don't calculate for the further ones because it has exceed our limit. Then it came back to here. We have tried 1 1. Then what we can try? We can try 1 2 also. 1 2 also we tried, so it is still so smaller. Then we again added it another value, that is 5. 1 2 5. It is also forming a set. We again pushed it. Then we again tried 1 and return. After this we returns like this. So after that we again tried 1 2, next was 6, but it exceeds our value, so we again returned. That means there is no matter of forming more combination here. That's why we returned here. Now what we have tried? 1 2 1 1 1 2. Now what's other we can try? Similarly we can try 1 5 also like this. Then again we add 1 5 7, but it's greater, sorry 6, so it returns. So like this we also form one another player, that is 1 7. This can also be formed from here. Okay, so after this we have tried 1 10 also. After this all that it returns, finally returns to its base where we have started for 1. Now we start for 2, but first we can also try for 1, but it will also form the sum of the pairs. And then again and again we will definitely reach at condition when we start for our 2. So when we start for our 2, that means our first element will become 2. Then again it will form another pairs like 2 5 2 6 2 7, as like this only. So among which 2 6 we can also get one pair, and it returns. So after all these combinations like this, where we ran for all the values, like for 1 for 2 for 5 for 6 for 7 for 8, we form a tree something like this. So let's write down its pseudocode to understand it more clearly. Then you will understand definitely. Let's write down our main function. This is our main function. First we created a resultant vector and also a combination vector, and then we called our function. It is suppose our backtrack, where we passed our nums, our target, at our index, that is at starting it will be 0, a combination, and our result. Then what we will return? Definitely our result. Okay, so now our backtrack function, which is our important function, it contains the same values. Here it will be called as index. First of all, what we will check? We will check if our target has reached 0. That means our values are totally good and we can return from it. That means we can directly add it to our result dot push underscore back. That will be our value, that will be our combination that we have created like this, and we will return. That means we don't have to try, means we don't need to add further more values here. Then what will be our next condition thing? Our next condition will be nothing. We will definitely go to our for loop, means we can try the other combination because we have not reached. That will be for I equals to, we will start from index until I is smaller than our num size. We will keep on adding, we will keep on traversing. Okay, then we will check if our I is greater than our index and our our value means our nums I equals to our nums I minus 1. Now what does that mean? We will simply continue. I will explain you. So it means, suppose this was our string, like it was on our question, and our index was here. Okay, so we don't want to repeat the, as we have to keep this mind that we don't want the repeating numbers. That means our combination shouldn't have a repeating numbers. That's why we have used this. That means on iteration, when our I reaches here, for example our I is here, so we will check that our I should be greater than index. That means our I is definitely not our index, and the nums of I is equals to a nums of I minus 1. That means these both are same. So what that does that mean? It means that they are definitely repeating. That's why we'll continue. We don't use these. We will continue from this iteration, and we will definitely, and on next iteration we will jump to 2. Okay, that's we have done this. Otherwise there are very much chances that we got the same pair again. How that so? Cause like this, in this example you do, we can get a pair like this, ones and this 7, and when we try to traverse from this also, it will again give us 1 and 7. So you understand, that's why we skipped this value, so that we don't form another pair like this 1 7. We can use it with this like 1 1 and then 6, but we can't use like 1 and 1 separate to form separate pairs, because it will leads to same pairs. That's why we did this. Okay, then next what we will do, now we will also check that does we have exceeded our limit. If a target is smaller than our nums of I, we will check this also, that if a target means, let's suppose we only need 2 now, but our value is 3, so that will lead us negative. That's why we will simply break it. Means we don't need to traverse further, because it will, if we move further we will definitely get more greater values. That's why we will break from here. So if that's not the case, then what we will do, that means we are safe to traverse, then we will simply do combination dot pushback or nums of I like this, and we will call our backtrack, and we will definitely pass our values like this only, same nums and target, and before passing we will minus that value that we have pushed, because we have added it. And our index, what will we will be passing to our index, we will definitely passing the I minus 1. In previous question which was same like this, we have passed I because we can use the values again, but here we don't want to use that values, we have to be safe from duplicates. That's why we pass the next value like this I plus 1, and then the same our combination vector and resultant vector like this. That will help us to make new combination like this, like 1. Now it will pass to another index like this 1 1 or maybe 2. That's why, and when it returns we will pop that value, so that we can try another combination like we discussed. It's like this, when we passed 1, then when we return we will pop this like this, so that we can now try another combination on it, like 1 2 instead of 1 1 we pop this 1 and we return, and then we tried for 2, then we again pop, then we tried for 5. This is how it works. Okay, then that's it. This is a pseudocode. After all this traversal we will definitely get our resultant string, and we will return it, and that will be our answer. Okay, so this is how you approach this problem. You must try this at home. Do the dry run as much as possible to get the clear idea of this question, how this approach is working. and I will provide the code below. Here is your code. Like we discussed, it's same. We create a resultant vector and a combination vector, then we sort it. Oh sorry, I forgot this. Here should be an important part also, that you must sort. Okay, I forgot that part, but it's a crucial part, that you must sort the list before passing it as a to our function. Okay, so we must sort our vector. After that, what happens? Here we call our function and pass the parameters, and our index is 0. Then it checks our target value. If it already forms 0, then we add our combination to a resultant vector. If not, we jump onto a loop and then we check a condition to skip duplicates like this. Then we also check that if our candidate value is greater than the target, so we break down because it's greater, so we don't add it, and we will not check for further. If not so, we will definitely add that value and call the function for the next value, for the next index, but first by subtracting that value to our target, and at last what we will do, we will pop that value after when all this function comes back from backtracking. Now let's discuss the time complexity. So the time complexity for this question, for this approach, is big O of n log n plus 2 to the power n. This will be our time complexity. Why so? Because it is the time it takes for the sorting part, and it is the time it takes for our backtracking. Because for each value there must be two cases now, that either we take it or we don't take it. That means the value becomes 2 to the power n. That's why 2 to the power n cases will be formed. That's why our backtracking is takes this much time and this takes this much. And what's our space complexity? Our space complexity will be big of n plus big of n plus big of n. One for the stack that we are forming during backtrack, one for our result storing, and one for our combination. And at max they can be n. That's why our space complexity will be big of 3n, or we can say big of n only, because constant have no value here, so we can remove the constant. So that's it. This was our question, this was our code, pseudocode. This is how we approaching our problem, and that's it. You must try this home, and till then, stay safe. Thank you.